just want to start with what I call some rule of thumb. So bear with me. You always like to set rule of thumbs, and today's rule of thumb will be coming from a quote from James Clear, who said that you don't rise according to your habits, or you don't rise according to your goals. You rise according to the systems that you build. And I would basically just say this in one word. Everything that we're talking about with artificial intelligence is a function of systems. The reason why a lot of people are struggling with AI is because they haven't learned the art of systemizing what they do. And you would see that as we go through today's session, it will basically just be a discussion around system thinking. How do you build a system that gets to think? I'm very, very practical and pragmatic. So at the end of today's session, everyone here must be able to, that's my end goal, to use any AI tool of their choice. Now, when I mention AI tool, it's a large blanket. There's a whole lot of tools out there, but you be able to at least specifically use a few. And it really doesn't matter which tool you use. What matters is the system that you build around these tools to give you the insightful responses that you need. So today's session is just basically what every beginner must know about AI. Even if you started using an AI tool or you use some form of AI tool, you need to have this understanding, and that is how you will get better with AI. Before we get in, a few rules. The first rule is come with a beginner's mindset, because in the mind of the beginner, there are a lot of possibilities. But in the mind of an expert, there's nothing more to learn. And I say this from a place where Alvin Toffler said, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. So see this classroom session as an opportunity for you to unlearn, relearn, and most probably learn a few new things. I'm not going to bore you with details about myself. I started out as a database engineer, but over the years, I'll be specific, from 2020, I was reading a newspaper article, I think it was the New York Times, and that said that the company that I was consulting and doing projects for at the time, Oracle, was launching what they called an autonomous database. And it was a database that would self-heal itself. So if the database had a problem, it would ask itself, do a diagnosis of how I'm doing. If I'm not doing very well, propose a solution and fix the database. So when I read that article on the New York Times, I told myself, I said, Michael, you're going to be out of a job very soon. And that led me to asking a lot of questions, doing a lot of soul searching. And that's what forayed my path into AI. I went on to do a management master's in artificial intelligence with Queen's University in Canada. And after that, I went on to do a doctorate program in AI ethics. So we're one of those who red team the use of AI. We want to make sure that people use AI rightly. And I'm currently in the classroom again doing a doctorate degree in generative AI, basically talking about the areas of how to ensure that we use generative AI in the right way. There's a lot of confusion out there. Everyone's talking about AI, everyone's talking about generative AI. Some people say ChatGPT is AI. Some people say cloud AI is the best AI. Today is not going to be one of those conversations. Today's conversation is going to begin with, let's even understand what this whole thing is about. So that's why I said, let's come with a beginner's mindset. Let's be open to learning. Let's ask a lot of questions. And having said that, let's get into the world of AI. So this is my quick agenda. I don't know why I'm getting this X's. Does it mean that, uh, Ty, I don't know. I'm seeing some wrong marks on the screen. I don't know if it's,
Okay, I'll take a look at it. I'll check.
okay, please. Yeah. Okay. All right, sure. Just want to make sure that it's obviously not me because I'm not annotating my decks, and I want to make sure that it doesn't ruin the viewing experience for others. So a quick agenda. This session is going to look at what is artificial intelligence, what is machine learning, what is neuro-linguistic programming, sorry, what is natural language processing? I always mix up NLP and NLP. What is generative AI? And then I walk us through the five senses, the five human senses. That's our sense of vision, our sense of hearing, and how that was used to build AI systems. And then we'll get into how large language models work. Once we get into sessions 2 and 3, I would have to open up a few AI tools, and then I'll begin to speak to how this works in the real world. My expectation is that after we go through sessions or agendas 2 and 3, agenda 4 will be a lot easier. That's prompt engineering 101. Okay, so Okay, so let's start by defining artificial intelligence. I always like to, whenever I teach, I always encourage my students to take any concept that has compound words and separate the compound words and define or understand the compound words, the individual words, before bringing them together. And so we're going to do that today. So if we take the word artificial intelligence and separate them into 2 definitions, we would get artificial, which means it is man-made. It's not natural. So artificial intelligence is not like climatology, that is the study of the weather and the climate. That has been there even before the first man went on to study it. No, artificial intelligence means it didn't exist, was created by humans. Now, the second thing is intelligence, the ability to think, to learn, and to solve problems. Now, what does this basically mean in less technical terms? It means if we bring the definition of artificial and intelligence together, we will be dealing with a study that was created by humans that allows machines to think, to learn, and to make decisions like humans would. So in less technical term, artificial intelligence can be defined as giving a computer a brain, but feeding it with enough information that that brain can solve a problem. Now, if I take us into the real world, maybe go into Hollywood, I don't know if everyone here would remember the series Fast and Furious. In one of the seasons, I'm not sure if it was season 6, there was a discussion about an equipment that they call the God's Eye. And if anyone followed that series, you'll see that in that, I think it was episode 6 or part 6, they found an equipment that could look at every camera anywhere in the world and be able to pick a picture of someone, facially recognize that person, and tell you where that person is just from any camera in the world. Now, we haven't attained that level of intelligence yet with AI, but that movie was just a representation of how humans can think when they are given all of the resources that they need. Now, we can't discuss artificial intelligence in isolation of machine learning. I know this is the boring part, but I want to break it down so that we get to understand this. Now, remember, we said artificial intelligence is made by humans. It is you giving a computer a brain that gets it to think. But before the computer can get artificially intelligent, it needs to learn. And that is where machine learning comes in. So how does a computer that we use to define as an input-output device that would give us garbage in and garbage out. Now get to a point where it becomes very intelligent that it can help you write an essay. This is where machine learning came in. So machine learning is basically how a computer learns from data. Now, the difference between humans is we learn from experience. Like real life scenario, if a child, if you tell a 1-year-old or a 2-year-old not to go put their hand in a gas in front of a gas flame or in front of a fire, they won't listen to you until they put their hand and then they experience a burn. Now, once that child experiences that burn, if it sees anything close to fire, it won't even want to go close. This is how human beings learn. We learn from experience. But machine learning, when we're dealing with machine learning, the computer learns from the data that you supply or feed it. Now, I'll prove something to everyone very quickly. I'm just going to open, because I don't want this to just be, okay. Let me call Chrome. Yeah, just open Chrome very quickly. I'm going to open my browser and, okay. Yeah. I want to prove to everyone what machine learning truly is. And to do that, I'm going to log on to ChatGPT. Okay. Just give me a minute. Now, what am I trying to prove? I want to prove to everyone here that this machine has learned based on certain books. So I pick a random book. Maybe the book I want to pick is The Richest Man in Babylon. So I'd say to this machine, or AI if you want to call it that, give me the top 5 lessons from the book titled The Richest Man in Babylon. My apologies, I need to change this to instant, so it's going to give me instant answers. Yeah. Okay. So this is obvious that it has been trained or fed the book, The Richest Man in Babylon. Now, let's do the same exercise with a book that has not been written. Give me the top 5 lessons from the book titled.
Okay. Hello, Mike.
Yes, please.
Yeah, we're not seeing the screen.
Oh,
We're
my
just seeing your
goodness.
slides.
Okay.
Yes,
Oh,
please.
sorry. I think I know what happened. I must have shared only. Let me share my entire screen. Oh, okay. You're not allowing me to share my entire screen. So I think that's what the problem is. I can't share. I can't share the entire screen. Hello?
Okay. You're not able to.
I'm not able to see entire screen. Normally, when I go to Zoom, it allows me to share entire screen, but I don't see that right now. I only see share applications. I think that's the problem. Yeah, it doesn't allow me to share everything. Can you check from your own end?
Okay,
But
I'll check now.
just check, but I would just share what I'm speaking to. Can everyone see my screen now? So
Yes, sir.
okay.
Yes.
So I'll
Yeah, we can see.
okay.
Sir.
So I said, give me the top 5 lessons titled from the book titled The Richest Man in Babylon. See, give me the top 5 lessons, right? Now, I want to ask you.
Sorry, Dr. Mike. Can you hold on a second?
Okay.
Please, when the facilitator asks you questions, reply in a chat. Don't unmute. Please, we don't want anyone talking. Don't unmute yourself. Reply in a chat. Thank you.
Okay. All right. I will share again. Okay, so I'm assuming everyone can see my screen now. Okay, so I'm going to, what I was trying to illustrate was the approach, the concept that large language models, or what we call ChatGPT or Google Gemini, or all of those AI tools, have been trained by certain data. And so I come here and I ask it a question. The question that I ask it is, give me the top 5 lessons from the richest man in Babylon. It has been trained with this data. So very quickly, it gives me the top 5 lessons. Now, I'm going to ask it to give me, so I'm going to ask it to give me the top 5 lessons of the perfect university in the world. I know there's no such book that has been written, but this is what's going to happen. It will either tell me that book doesn't exist, or it will make up a story, or it will make up a response. Now, see, first thing it does is excellent. It says, I wasn't able to locate a book titled The Perfect University in the World. It's possible that it's under a different title, but then he went on to look for a book called Toward a More Perfect University, and then shared the 5 lessons from that book. Now, let me stop sharing and go back to my slide. But I'm sure with everyone here listening, you now get the idea of what machines are, or machine learning is. If you have not given it that data, it cannot share any experience from what you haven't given to it. Our legal friends would say, nemo quod non habet. You can't give what you don't have. And so that's what machine learning and artificial intelligence basically is. Which is one of the reasons why the limitation of artificial intelligence and machine learning are that if you've not given it that information or that data, it can't give you the answer that you require from it. Now, that limitation got AI engineers to go on and start asking certain questions. And that led to the creation of newer machine learning approaches, which is where deep learning came in. Now, deep learning, as well as natural language processing, as well as what we call generative AI today, were built because people saw that there was a limitation to machines learning information that was being supplied to it. So they started to think, how about if we build machines that have a brain, or that think like the human being, or the human brain? Let me put it into context. So in order for them to achieve that, they created what was called deep learning architectures. Now, in deep learning, what they basically did was they took computer models and built them into layers. I don't want to get into talking about the human brain, but the human brain is made up of neurons and what we call dendrites. So every time you want to remember something, you have to send it to short-term memory first. So before it then goes on to long-term memory. So deep learning basically allowed AI engineers to build machines that think like the human being or the human brain. Without trying to make it very contextual or very, without making it too difficult, just think about having 5, 10 layers. And every time you ask a question, the question is taken from layer 1 through layer 2, through layer 3 till you get to layer 10. Now, at some point in time, when you're in layer 3, if the model feels you have enough answer, it skips the other layers and gives you the answer. And then it moves on. But deep learning sets the pace for what became generative AI, or what we call ChatGPT and all of those technologies today. But they wouldn't have done it in isolation. They had to leverage language understanding. If I go into the chart, I would see that there are some people from the northern part of Nigeria, there are some people from the eastern part of Nigeria, and there are also people from Lagos and the western part of Nigeria. We all we have different dialects and different languages, right? Now, there has to be a common language that all of us understand, and that would either be that would either be the English language or what we call Pidgin English. So for us to be able to communicate across the three different regions, we would have to speak a common unifying language. Now, natural language processing helps us fix that problem. What was basically done was we took computers and got computers to understand how humans talk, how humans write, and we now enabled computer to be able to understand human language. That's what became natural language processing. Now, if you think about this, if you have a computer, or let's even go back to 10 years ago, the computers we're using 10 years ago, we couldn't speak to them. We could only type and print. But today's computers, we can speak to the computer and the computer would respond to what we have said with answers. I'm going to show that to us, but after a few more slides, so that everyone connects to what we're talking about. So natural language processing allows computers to process language. Now, so remember, we've come from, I'll go back to the beginning. We've come from artificial intelligence, machines understanding how to think, learn, solve problems. Machine learning, feeding data into machines so they can think like humans. Deep learning, building the machine to have a brain of its own so it can remember conversations. This is one of the benefits of deep learning. Now, natural language, understanding our own language when we ask the computer a question. And then today, we have taken all of those fields, machine learning, artificial intelligence, deep learning, natural language processing, and we've brought them all together into one application, which we call generative AI, which is AI that allows us to generate new content. So in less technical term, the word generate allows you to produce something new. So if we have machines that can think, that understand our language, and can act smartly, then the next phase for us is to generate anything we want out of that machine. And we're getting there shortly. I just want to show you that that is possible. And I'll skip this slide. I'm not skipping it completely. I'll come back to it. But I want to speak to the 5 human senses. Now, this illustration on the screen tells us that every human being takes in information from the 5 senses. So we see, we hear, we touch, we use our nostrils to smell, and we use our mouths to either confess or give out information. Now, every time as humans that we receive information, what happens is that information gets into the human brain through a couple of filters. Now, the filters allow us to generalize data, to distort data or to delete data. So this is a typical example. Mary had a little lamb. The fleece of the lamb was white as snow. So I can safely generalize that every lamb has a fleece that is whiter than snow. That's generalization. But in order for our brains to be able to generalize, distort, delete, or finally interpret what we understand, it needs to take that information that we have passed into the brain and break it into smaller chunks, which is then passed to other parts of the brain to interpret, to store, and to provide back to us as a behavior. Now, why did I take the time to explain this? Because this is the same thing that has been deployed in the world of computers today. The five senses inspired artificial intelligence as we know it today. And I'm going to prove it to everyone. Maybe with the eyes and the ears, but maybe without the exception of the skin, because we do not have a robotic equipment here. But for those who have robotic equipment, they can use their robot, plug their robots to a computer screen, and it can provide some level of answers to questions. I'm going to stop sharing, but I'll reshare my screen again just to showcase how we can use computer vision and speaking to a computer to get some answers. Just going to take this down so it doesn't stand in my way. Guess everyone can still see my screen. Okay. So just get this out of the way. I believe everyone can still see my screen. So I'm going to open this again. Now, first thing I want to do is I want to speak to this computer and prove to you that it understands natural language. So I'm going to allow it to use my computer. Hey, chat, I want to say good morning to my friends from the western part of Nigeria, and I want to say good afternoon to my friends from the eastern part of Nigeria, and I want to say good evening to my friends from the northern part of Nigeria. Can you help me generate a statement that I can send to the large language model to give me this answer? So this is what we mean when we say natural language understanding. So every time I click the dictate button on ChatGPT or any of the large language models and I start speaking, it hears me and it understands my language. That is what natural language processing, natural language generation, and natural language understanding has been able to fix. Now, if I take this same message and I send it to the model, it has already been trained in the different languages. So it says to me, it says, based on what I sent to him, it says, write me a greeting that says, good morning to my friends from the west, from the east, from the north. So it's just corroborating what I've asked, the question I've asked. Now, if I throw that question, I've now given it an instruction. Okay, so now I think it's beginning to, okay, so maybe I threw in too many elements. Let me say, write me a greeting that says good morning to, maybe it doesn't understand western part, so I'm going to say, so to the, okay, we'll move this upward. Oh, okay, that's interesting. So now, okay, hold on. I'm using the instant model. Let me see if that's, okay, see. Let me just be very clear in Yoruba. See what happens. Sometimes these models just hallucinate. Okay, let's see. Aha, okay. So probably because I gave it too much context, so it was struggling. So see, I said, write me a text that says this, good morning in this. Now I can do the same thing for any other language because it has been trained with these different languages. If I ask you for a language that doesn't exist, okay, let's say for example, I'm not sure if ChatGPT has been trained with Ibibio. So if I say, send me, write me a greeting that says good morning in Ibibio. Let's see if he finds Ibibio. Oh, okay. So it's been trained with Ibibio and a couple of languages. But the idea I'm just trying to bring out here is once you click on this, you can have a natural language understanding. So the AI models can understand you when you speak. Now, I'm going to try to speak to the model, and the model will also respond to me, and then we'll go through the last one, which is vision. Okay. Hey, chat, can you hear me? How's it going?
I can hear you loud and clear. It's going great on my end. Hope you're doing well too.
Yes, I'm doing well. I just wanted to know if you could help me define the difference between deep learning and natural language processing. I'm speaking to individuals who aren't very tech savvy, but I just want them to understand the difference. Can you help me with that, please?
Absolutely, I'd be happy to help with that. So here's a simple way to break it down for folks who aren't super tech savvy. Deep learning is like a big, powerful tool or technique. It's a type of artificial intelligence that uses structures called neural networks, kind of like layers of artificial brain cells, to learn patterns from a lot of data. You can think of it as the underlying engine that can be applied to all sorts of things, like recognizing images or making predictions. Natural language processing, NLP, is one specific application of AI and often uses deep learning as a tool. Basically, NLP is all about helping computers understand and even generate human language. So whenever a computer is figuring out what you mean in a text or talking back to you, that's NLP at work. In short, deep learning is the broad, powerful technique, and NLP is one of the ways we use that technique to handle language. Hope that helps them get the gist.
I hope so too. Thank you, chat. Can you clarify the difference between generative AI and I don't know, and all of the terminologies, AI, ML, deep learning, natural language processing? How does generative AI tie into all of these existing AI technologies?
Absolutely. I'd be glad to clarify that. Think of it as a bit of a layering or nesting doll situation. At the broadest level, we have AI, artificial intelligence. That's the big umbrella term for any technique that enables machines to mimic human intelligence, whether it's making decisions, recognizing patterns, or something else. Under that umbrella, we have machine learning. ML is a subset of AI focused on teaching machines to learn from data. Instead of being explicitly programmed to do a task, the machine learns patterns and improves over time with more data. Now, deep learning is a subset of machine learning. It uses these multi-layered neural networks we talked about to handle really complex tasks. It's especially good at dealing with large amounts of data and figuring out intricate patterns. Then we have natural language processing, NLP, which is a field within AI that deals specifically with understanding and generating human language. And as we said, it often uses deep learning as a tool to achieve that. Finally, generative AI is a type of AI that focuses on creating new content. It can generate text, images, basically producing something new that wasn't there before. Generative AI often uses deep learning models to do this. For example, when you hear about language models that can write stories or code, or image generators that create artwork, that's generative AI at work. So, in summary, AI is the big umbrella, machine learning is a subset of that, deep learning is a powerful technique within ML, NLP is one application area of AI, and generative AI is a specialized type of AI that creates new content, often using deep learning to do it.
Amazing. Thank you very much, chat.
You're very welcome. I'm glad I could help break it down.
Sure.
If you have any more questions or need anything else, just let me know.
Okay, cool. Sounds good. Thank you. So in a nutshell, I've just had a conversation with my large language model. Now, this is where it gets interesting. For all that communication that I had, it actually generated a transcript. So, speaking from a pragmatic point, this is one of the reasons why AI is going to help change the world we live in today. Someone comes to me and says, oh, I'm very lazy. I'm not able to sit down to write a book. I said, speak to any of these LLMs. Tell it what you want to do. It will help you flesh out your idea and you'll start cranking out chapters for your book. This is where the world is going to today. Now, I'm not done yet with showing you how AI use the 5 senses of the human beings. Now, of the human being, I'm going to go to a popular archive site that I call arxiv.org. I mean, every AI researcher actually goes here. So if I want to read any research paper on any field, I can just come here. I can get those papers for free for now. Now, let's say in my own case, I just want to look for understanding large language models. Now, I'll tell you where I'm going to with this. Okay. So I do a quick search for any paper that helps me understand how large language models work. Okay. I don't want something too complicated. Okay, let me go back. Let me just use a regular understanding LLMs. That's Axel article. So I've enabled ChatGPT search. So every time I search on my browser, what I actually do is, instead of using my Google search, I leverage ChatGPT search. So it's going to give me this particular paper. This is the paper I'm looking for, Understanding Large Language Model Powered Human-Robot Interaction. So I'm going to open this paper. Just want to show you how AI was built to think like humans. Now, this is the paper. Okay. Sorry, so many things opening up on this laptop. Now, let's say I go to visit a friend of mine who is also an AI researcher. And we are having a conversation and he says, I think you need to read this article. I'm like, what article is that? And then he shows it to me and I say, oh my goodness, I don't have a pen. Neither do I have a paper to take the name of the article or who wrote it. And he says, why do you have to do that? Just take your phone and take a picture of the article. So I'm in front of my laptop. So I'm going to use my sniping tool, which allows me to take a picture of the article. So I take a picture of the article. So I have a picture of the article. And then I go to my large language model. It doesn't have to be this one. Maybe just go to this one. And I say, I want you to help me find this article based on this, based on this picture that I have shared. So this is computer vision. Anytime the computer sees something, it translates that vision by converting it into sets of chunks and then goes into the AI or the model to look for that information. Now, it's going on the internet. It has searched for that document and it has found the link. So if I click on this, it obviously takes me to the same article. This is the same article, but if I just click view PDF, yeah, so that's the same article. So what I just wanted to showcase here is the fact that I'll stop sharing for now. So I'll go back to my PowerPoint slide again. Is to showcase to everyone here and justify the argument, because there's a lot of people who have an argument that AI is well, so many analogies. Some people said there are actually human beings who are working behind the scenes to give you the responses that AI is supposed to give to you. But I've just in a very few set of sessions just shown you that the artificial intelligence, machine learning, deep learning, NLP stack plus the Gen AI stack was basically built to think like we humans. So they use their own eyes or our scanners to see. They hear what we tell them to do, either as verbal instructions or as typed information. They use robotic hands. For organizations who have started using robots, those robotic hands are passed instructions or softwares are deployed to them. And then they go on to process the transactions or the instructions that we've asked. Now, why is this very important? I often say that if everyone understands how large language models work, it makes our work or our lives a lot easier. And it will take us to the next set of things we are going to start talking about. Because now that we know that large language models take information from us, so we are the input entity. Now, the question is, what output do you want at the other end? That's the question that I want everyone to begin to process right now. I know you have questions that are already coming, but just save those questions for the next 4 to 5 minutes, because we're going to take a 10 minutes Q&A break, and then we'll continue after that. So remember, I said your AI models can see, if you scan and upload a document to it, they can receive input from you, still you supplying information, right? And they can also hear you speak and then respond. Now, if we give our language models the right input, we will get the desired output. But the challenge has always been, when we don't send the right input, we cannot expect the desired output. And this is where prompt engineering comes in. I don't like calling it prompt engineering. I prefer to call it context engineering, because if you give the large language model the right context, it will give you the desired response. But before we get into prompt engineering, which is going to be the next session we'll get to after the Q&A break, let us understand how a large language model works. Without complicating it, we have an encoder. So every time you send a question to ChatGPT, to Claude AI, to Google Gemini, or any AI model, all you are basically doing is you are sending information to an encoder. The encoder takes your input, breaks it into smaller chunks. Remember when we talked about the human brain also breaks things into 5 to 9 chunks, right? So large language models also break things into smaller chunks. But in AI terminologies, they don't call them chunks, they call them tokens. So if the AI doesn't understand your tokens, it will not give you the kind of answers you desire. So an understanding of how to break your questions into tokens is what will enable the model to have the attention mechanism that it needs to decode and understand the output that you desire and then give it back to you. Now, I can prove this very quickly. If we ask any large language model, whether it's ChatGPT, whether it's Claude AI, whether it's Google Gemini, what is the color of the sky? It will give us a response. The color of the sky is blue. So that's how large language models work. You throw in an input, you either ask it a question or you give it a sentence, or you scan a picture and ask it to give you information based on that picture. It breaks that text into tiny units called tokens. I already explained this. It finds the patterns from the data and gives you the output that you desire. So if you say to any LLM, write me a poem, it will give you a poem. But the question is, did you give it enough context to write the poem? And so this is basically what it looks like from a, so the first diagram is a non-technical diagram, right? This second one is somewhere in between high level to a little bit of details, right? So large language models was built with what we call the transformer architecture. And every transformer architecture has an encoder and a decoder structure. So it takes the data, encodes it in a way that computers can understand. The computer must understand what the instruction you send to it, otherwise it won't be able to decode it. And then in order for it to decode it, it passes that data through neural networks, which is our deep learning. And then based on how well that deep learning model has been trained, that's when you get an answer. So the most important lesson for us at the end of this first session on AI beginners is we now understand that what we call ChatGPT is not AI. They are large language models. They have been trained with data. They are a machine. They can generate new data based on the deep learning models that data has learned the data that you pass through it from. And in a nutshell, everything that we've spoken about today falls under the umbrella of artificial intelligence, and it was built by man. I'm going to stop here, and I hope that with these few points of mine, I have been able to clarify what artificial intelligence is. Thank you. I'm going to look for questions.